Okay, so for this next example, it tells you again, all right, what we're trying to do is determine if it's a parallelogram, but this time it's saying using the distance formula. Ha ha ha. All right, so if we go back up, all right, to the different ways of proving it is a parallelogram, this one would actually fit into the second one, because if we could prove that the opposite sides are congruent, then we could state that it's a parallelogram, all right? But bad news bears, guys, how many times are we going to have to do the distance formula? Well, we are going to have to do it 4 different times, all right? So we would have to find the distance of JK, of KL, of LM, and then of JM, okay? And if we remember, our distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so that's our distance formula. Now listen, I went through and I did these, all right, because I'm not going to take the time to go through and do the distance formula 4 different times, okay? So here's what I found. I found that JK was the square root of 26. All right, KL was the square root of 53. LM is the square root of 37. And then JM was the square root of 50. And so if you take a look here, all right, this doesn't look great because if it was a parallelogram, JK would have to be congruent to LM, and then KL would have to be congruent to JM, and neither of them are congruent. So the answer to this one is no. All right, it's not a parallelogram, okay? If it was a parallelogram, then they would have to be congruent. Now, our next one says, determine if the following vertices make a parallelogram using the midpoint formula, okay? So again, we're going to go back up here and say, well, how would the midpoint formula help us, right? So would it prove that opposite angles are congruent? No, it wouldn't, all right? But would it prove that the diagonals would bisect each other? And that's exactly what it is, all right? So what the midpoint formula is going to do to help us is if we found the midpoint of both of those diagonals and they're the same point, all right, then that would make it a parallelogram, okay? So if I have this parallelogram of A, B, C, and D, all right, I'm going to have to find the midpoint of AC because that's a diagonal, and then I'm going to have to find a midpoint of BD because that's a diagonal, and if they match, then it's a parallelogram, okay? So if you guys remember, your midpoint formula is x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. All right, so doing it for AC, I would do 0 plus 5 divided by 2, and then 0 plus 7 divided by 2, which would give me 5 halves, common 7 halves. And you can change those into decimals if you want. It doesn't matter to me. Now let's do it of BD, all right? So for BD, I'm going to do 2 plus 3 divided by 2, and then 6 plus 1 divided by 2, which gives us 5 halves, comma 7 halves. And now if you take a look at your 2 midpoints, do they match? And the answer to that is yes, they do, all right? They do match. So if this is the case, then yes, it's a parallelogram because the diagonals bisect each other. Okay, so here's what I want you guys to do. I want you guys to come down to this next section, all right? And I want you to pause me now, all right? Well, after I finish this. And determine if you have enough information to state if the quadrilateral is a parallelogram, all right? And I'm going to go through these, so you don't have to explain your answer. So really what you have to do is just say yes or no, okay? So I'm going to pause for a couple seconds. Pause me now, all right? And then play me whenever you are ready to double check. Okay, so let's go over these. The first one is no, because you do have that these 2 angles right here are supplementary, but that would only prove that these 2 sides right here would be parallel, and you don't know about the other 2 sides, so that's not helpful. So the answer to that is no. The second one is yes, because of opposite sides being congruent. The third one is yes, because opposite sides are parallel. The fourth one is no, because it does have adjacent sides are congruent, all right, but it doesn't have that opposite sides are congruent, so that's not a parallelogram. The fifth one is yes, because of opposite angles are being congruent, and the sixth one is no, because even though these 2 angles right here are congruent, These ones right here are not, and you have to have both sets that are congruent. Now, this one doesn't look like we have enough information, but if you could find what this missing angle is here, you would find that this is 60, all right? Because you'd have to do 360 minus 120 minus 60 minus 120 to find that that angle right there is 60. And so if that's the case, then the answer to this is yes, all right? And it could be for multiple reasons. It could be because that the opposite angles are congruent, but it could also be about the fact that the same side interior angles would prove that the opposite sides are parallel. But obviously the opposite angles ones is easier. All right, this one is yes as well, all right, because the diagonals bisect each other, because you have one tick mark, two tick marks, two tick marks. And then the last one is a little bit harder, but the answer to this one is also yes, because even though all four of these are congruent, they're still bisecting each other, right? Which means that that point is still the midpoint of this side, and it's still the midpoint of this side. It just so happens that all four segments are congruent, all right? Okay, that's it. That's the notes for today. I hope it made sense. Let me know if you have questions. Remember, what we're doing tomorrow is a bunch of proofs.